In 2024, question 2 is complex numbers. We have a quadratic here that clearly doesn't factorize, so we're going to have to use the quadratic formula, and there's a clue in the question. So we're going to get minus 12 plus or minus the square root of b squared minus 4 by a by c all divided by 2a. So that's going to be minus 12 plus or minus the square root of minus 900. That's equal to 30i. The square root of minus 900 by the square root of minus 1 plus 900. And that's over 2. So we're going to get minus 6 plus or minus 30i divided by 2, 15i. Part B, de Moivre's theorem, to write 1 minus root 3i to the power of 9 in the form a plus bi. So I think it's good habits to sketch it first. We're going out 1 and down root 3. So we can find the angle A. The tan of A is equal to root 3 over 1, just root 3. The inverse tan of root 3 is 60, so therefore A is equal to 60 degrees. So the angle we're looking for, theta is equal to 300 degrees. 60 is pi over 3, and 300 is 5 of them, 5 pi over 3. Or is equal to the square root of 1 squared plus root 3 squared. You've seen this come up all the time, you know it's equal to 2, but you still have to show your work. So now the complex number is going to be 2 by the cos of 5 pi over 3 plus I times the sine of 5 pi over 3. So if we want this whole thing to the power of 9, we call this z. Z to the power of 9 is equal to 2 to the power of 9 times the cos of 9 times 5 pi over 3 plus I times the sine of 9 times 5 pi over 3. 2 to the power of 9 is 512. And then we're going to have the cos of 15 pi, which is minus 1. And the sine of 15 pi is 0, so plus 0i. So we're going to have minus 512 plus 0i for this complex number. In part C, we have w minus 2 plus 2i, it's shown here. We're asked to plot and label this complex number u is equal to 4 times the cos of 30, which is root 3 over 2, plus the sine of 30 is a half, so a half I. So that's going to be 2 root 3 plus 2i. And 2 root 3 is approximately 3.4 with 3.4. 3.46 might be close enough to get to on the diagram, plus 2i, so out just below 3.5 and up 2. So here we are here. So this is the complex number u. The complex number O is 0 plus 0i, so the origin. So we now have this triangle that we're going to need to use. We're asked to find the angle WOU, so this one here. So there's a couple of approaches. If we create our two right angle triangles this way, we have this angle A, the tan of A is equal to, they're both 2's, so 2 over 2, which is 1, so A is 45 degrees. This angle in here is B. Does it work out evenly? Well, we have, what have we gone up? We've gone up 2 root 3, and we've gone out, we've gone out 2 root 3, and we've gone up 2. So the tan of B, yeah, this does work out to be an even number. Tan of B is equal to 2 over 2 root 3, which is equal to 1 over root 3. So B is equal to 30 degrees. So the angle C C is equal to 105 degrees. A plus B is 75. And in radians, the answer we want. So 15 degrees is equal to pi over 12 from all your practice. So we have 7 of them. So we have 7 pi over 12 for the angle to end this question.